this computer. And so Rachel will show us how to do a variety of processing on QGIS, and this will be using throughout the semester. And then we'll save about 10 minutes at the end to give you an introduction to that first assignments. And the reading or the YouTube video or the recording from today will then, I'll put it on YouTube later as well, so you can refer to what we've done today later as well.
Great. And so Ramon couldn't be here with us today. He's doing some SCEC proposal stuff, but he did record kind of an introduction video that we'll show you. And it kind of explains the type of data that we're going to be using throughout the course and what it means. And then also this really cool software called Open Topography that we're going to be collecting a lot of our data from. I'm sure some of you have heard it before. Do you mind enabling screen sharing, Chelsea?
Should be good.
Cool. So let me know if you guys can't hear this either, but I'll play his video to kind of give you guys a little intro to it.
I can't hear it.
Yeah, we can't hear it, Rachel.
That's unfortunate. Okay.
Rachel, when you start screen sharing at the bottom, there should be a little option that says something about share sound as well.
Okay. Oh, thank you.
No problem.
Okay, I'm going to give it another go.
This presentation is a short introduction to digital elevation models and open topography. So one of the big things we want to know is the topography of their service, because it's a key indicator of many processes. So the big challenge is getting the right coverage in time, space, and resolution for the questions. So when we say resolution, what we mean is basically the size of the pixels of the elevation. So on the left, you can see global and regional topography and bathymetry, which is tens to hundreds of meters per pixel and is usually from space-based platforms. So the workhorse is the Shuttle Radar Topography mission. It was collected in 2000, but we still use it a lot, and it's about 30 meters per pixel. In the middle, we can combine topography with bathymetry and have a global map. And then also there's some photogrammetric data coming from space that we are seeing resolutions down to 8 meters or 5 meters in places. But in most cases, what we've been working on is local to site scale topography, where the pixel sizes are decimeters to meters per pixel. So we often call this high resolution topography. And the main ways of measuring those data are airborne laser scanning, or terrestrial laser scanning, where we're shooting a laser pulse out and getting a return to our platform, which is either airborne or ground-based, and then computing the position of those laser returns in 3D relative to Earth-centered reference frame usually. On the other hand, what's become very popular in the last decade is structure for motion, or photogrammetry, where we use the motion of the camera, taking many pictures of the same area, and that will give us depth information. And then we say the scene structure refers to the camera positions and orientations and the topography. And so we used to use a balloon, but now we even use drones. So these are all sources of this high resolution topographic data. And this image on the right comes from this Johnson et al. Paper. So in detail, what we can say, especially for laser scanning, and so we'll talk about LiDAR a lot. So it's like radar, LiDAR. So the outbound laser pulse goes out and it interacts with the vegetation and the ground and reflects back. A lot of times we then would have discrete returns from that environment. And so we get this 3D view of points. And this little video on the bottom shows all the returns. And now I'm just showing the ones that we think represent the ground. So those would be the ground returns. And so that's a true 3D representation where it's X, Y, Z and intensity or classification for those points. But then what we do is we grid that, which means we go from 3D to something we might call 2.5 dimensions, where we represent it as a pixel-based or raster-based topography. And if we use all the points, we might have something called a digital surface model. And if we just use those points we think represent the ground, we call it a digital terrain model. So in this place in Northern California, you can see the DTM shows us some scarps that are en echelon fault traces from the San Andreas Fault. So then we could use these data to answer science questions. So in detail, the digital elevation model then is this two-dimensional representation of the topography. Sometimes we say 2.5D because it's like third dimension is elevation, but there's only one elevation per pixel. And so in this case, this is like a pyramid where the edges are 0 elevation, we go up to 400 meters or something. And so that grid resolution is defined by the size in the horizontal dimension of the pixel. So 1 meter DEM as pixels 1 by 1 meter assigned as a single elevation model. So that's the kind of fundamental product, a DEM, which could be a DSM or DTM. And so from that fundamental product, we can compute things like hill shades, which would be artificial illumination of that topographic surface, like from the northwest, or we can make contours, lines of equal elevation. So Open Topography is a site, a website, a project, and a portal that our goal is to democratize online access to high-resolution topography. So we have LiDAR, photogrammetry, satellite-derived data. We have a tiered access to data from raw point clouds to easy-to-use derived products. And we try to co-locate the data and processing tools. So www.opentopography.org. And you can see here the data services we have are this range of data types where we might have KMZ hill shades that are easy to browse to the digital elevation models to the point clouds. So this is kind of a direction of increasing data volume and computational demand, but also usually opposite of ease of use. So usually these KMZs might be the simplest. And then we have multiple access pathways, which include the web portal interfaces, APIs, OGC, web services, etc. But usually people come in via the web portal to access the high resolution data.
Cool. So that was a little intro to OpenTopo, and then I will show you guys the website. So this is the OpenTopo. I like it because oftentimes I feel like it can be a bit hard to find data sometimes, and you have to go through many different pathways. There are other options to get LiDAR data, but this is a nice kind of conglomerate of everything. And you can look up all the data. There's a whole data map. It'll show the different kind of satellite imagery depending on what kind of data you're looking for. You can click it, download it. It's quite nice. There, yeah. Now I will show you how to submit a job, I suppose, because that's how we got the data for the Wallace Creek, although we already put it up on the website for you guys. So once you get to the data map you would like to obtain from, I zoomed into kind of our mapping area, and you'll see that this red is the satellite that was used to collect it, and you can select a region and that'll be all of the points and within that data set that you'd like to collect. And you scroll down and you can see, yeah, Mara.
Sorry, which tab did you hit to get there?
So this was previous job I ran just because it takes a bit of time, but if you go back to the data map and you go anywhere, like let's say right here per se, you can select a region right here, and then it'll bring you to a similar page. It'll show you the different kinds of satellites that were used in that area that you can collect the data from. Some are going to be higher resolution than others. Like the Ramon mentioned, the global and regional DEM will be a lower resolution, but then we also have some of this high resolution topography where the resolution can range from like 1 to 10 meters. And then so once you choose that, you can go click either whatever you're referencing, the point cloud or raster data set, and it'll bring you to a similar page here. And so this was done for the Wallace Creek assignment that we're going to be doing. It used the B4 project, and this kind of gives you a bunch of information about the project. It tells you the resolution of it, and it'll show you again down here. This kind of just tells you how many points are in the area. If you choose a really large area and you're trying to obtain data, it will be too large of a file to process. If you do want
Rachel,
to,
can you go back up for a second? Just, yeah, so you said the resolution. So this is a point cloud data set. And wait, stop where you are. And so where you see point density, then that's the resolution. And so this is a LiDAR data set with about 3 points per meter squared. So it's pretty good data set. And you can see to the right is collected in 2005. So throughout the semester, it'll be important to know when the data that you are using was collected.
yes.
All right, go ahead.
Well, and so yeah, oftentimes you might select an area that's too large and contains too many points to process. And you can sometimes get more if you wanted to create your own account on this. It'll let you select more points and process more data. But sometimes you might have to just make a couple smaller boxes and separate out the data before you download it. And this point cloud, it'll just be different kinds of formats. You can get it. You normally put it in the LAS or just whatever it's referenced in. And then this will be the DEM generation. You can choose different formats to get it out of. We normally do the GeoTIFF because you can upload it into QGIS easily. I don't really mess with the gridding parameters or anything. And then the derivative products is where you can choose if you want. You can generate hill shade and slope grids already from the data, so you don't have to render them on your own in QGIS. So you can choose to download those if you want. You could also download a 3D point cloud browser visualization if you prefer. There's also kind of a way to do that in QGIS as well if you want to view something in 3D. And other options, if you want to visualize it, you can download, like Ramon was saying, some KMZ files, other color relief hill shades. I like having the hill shade already with me, so I click that. You can also do contour lines as well. And that'll give you like a line elevation model. You could also do that in QGIS, which we'll show you later. And then the rest of these are mostly for class learning, but if you do create an account and you want to run it, you can put it in, submit. It'll take a little bit of time to process, but it'll give you an email with a link to this job. So then it'll kind of cache into your account, so you can always go back and look at the job or modify it and resubmit it. And so now, unless anyone has any more questions about OpenTopo, we're gonna move to QGIS.
Yeah, let's give a few long seconds for questions.
Yeah, one more. What do you mean by job?
Yeah, sorry. The job is just like whatever you're whatever specific data you're wanting to collect. So they call it a job because you're making the software run something. So the job will entail like all of the products from you're trying to derive and download whatever data it is.
So a job is, yeah, as Rachel said, it's you making a request from OpenTopography for data. And so when you press submit, that then will start the job. And then a few minutes later, you can either keep this page open and you'll have a link to download the point cloud file as well as the raster digital elevation model. And if you close that window, then whatever email you entered on that page, you'll get a link to download the products.
And this will be what it looks like when it gives you an email that it's ready. And so if you want to look at the metadata of it, but the results of your job, you can click it here and it'll bring you to this page. It gives you the job ID. It's been a little longer since I first did it. So normally it'll show all the results under it where you can download the TIFF file, the Hillshade, all the files that you requested from them.
Rachel, will the point cloud density of the data affect the raster in the DEM that's produced, or is it just the same raster or same like pixel size for every raster that's produced?
Does the point cloud data affect the raster?
Yeah.
I think when you choose, you have to kind of distinguish which one you're choosing, because when you go back to the satellites, it'll ask you to choose point cloud or raster from the satellite.
I can answer.
Yeah,
As a part-time OT employee. And so data sets have greater than 1 point per square meter. So maybe they're 5 points per square meter. The default resolution will be 1 meter. If they're much lower resolution, say like 0.5 point per square meter, then the default resolution for making that raster will be will correspond to the density of the original point cloud. And so for the far majority of data sets, it's fine to leave the resolution for the raster that Open Topography suggests.
Sweet. So now we're going to go into QGIS. And so when you first open it, that'll probably say something like new empty project, and you can create a new project and save it however you like. You probably just have browser right here. So if you would like to add the layers, you can go to view, toolbar.
Wait.
Yeah, oops, sorry.
Rachel, so do you want people to download a data set or?
Yes, so yeah. I was gonna give them a little like lay of the land of QGIS and then talk about importing the data. So hopefully before you have gotten, you've tried to download the base map and mapping polygon for the assignment. And then just have that, it's similar to ArcGIS, where the location and pathway of your files is gonna be really important. So I like to create a folder for everything and then like keep it that way. Because if you try to move things or copy it, it can get convoluted and corrupt the data. And Mindy, do you have a question?
Yeah, I don't know if this will come up once you tell us how to do stuff, but I downloaded that from that link that you just showed, the polygons and stuff, and 2 of the items are unavailable.
Okay.
I don't know if that was like on my end or not.
Is anyone else running into that issue? I couldn't hear what he said, Rich.
Some people are able to download them, but when they try to open them, they're saying that it's unavailable.
The mapping polygon and the output downspace CE.
The mapping polygon and the what?
Output downspace CE.
And the output downspace CE files are showing up as unavailable.
Okay. Let's see if I'll just download them and see how it goes. If not, I can just send out an email to you guys that has it as well instead of just on the link and see if that changes anything.
Yeah, for me, it's just, you can't zoom to the layer, which is kind of weird.
Okay. So I
I got
will.
that info. Yeah,
Mhm.
that's what I saw.
Okay, I'll send out an email then with them separate, which will be better. It'll just be the shape file then for the mapping polygon, and then just the TIFF file that you guys will be able to download. Sorry about that. Okay, yeah, so I'll email them out to you guys. That might be a little bit better. I might have gotten something a bit convoluted when I was trying to put them on the website, but I'll just email them directly to everyone after the class is finished. So it's not a packaged file. I don't know if that had anything to do with it. But once we have those sorted, this is kind of the layout of QGIS. It's pretty similar to ArcGIS. It's nice in the way that you don't need a license to use the software. It's open source and it's a bit more user friendly, I think, and it's getting updated a lot more than ArcGIS, which is nice. But once you open this, you'll probably just have the browser available. If you do want to get the layers option, you will have to go to View, Panels, and then it gives you a whole slew of options of things you can add to the left side of the screen. I always like having the layers toggled and it'll add it in right there. And Chelsea, did you want to mention the plugin real quick before I go into add the data?
I think it should be there. So I'm processing the data right now on Open Topography, and it should be ready in a few minutes. So if people want to then follow along with Rachel. So if you have a newer QGIS, I don't think you need to do this, but if you, can you go to raster, Rachel?
Yes.
And then analysis. So if you have a new QGIS version, you should see all of these options here, in particular hillshade. Does anyone not have hillshade there? Okay, great. Means you all downloaded the newest QGIS version. All right. So you can keep on going. Chill.
Oh, I think like what Ben was saying, I should have exported the file instead of just like coded it directly into the website without exporting it separately. So I didn't have the tag to the pathway, which is what I just said was a problem. So learn from my mistakes, but okay. So granted you have these uploaded, there's the toolbars as well. I have a couple more than what you're given initially. So if you do want to add more toolbars, some advanced like processing, you can go down, same thing, and add some toolbars to the top. And another thing we want you guys to be able to do, just like get set up with everything, is to kind of peruse through here. The browser is going to be where you can find all of the data that you'd like to upload. It also gives you some options for base maps. It'll already come, I believe, with the OpenStreetMap, but we also want you guys to be able to look at satellite imagery taken from Google Earth. We won't have you guys rely on this too much because a lot of the imagery we want to give you guys is going to be happening before the earthquake has occurred. So you'll probably see remnants of it that we would not like you to see because it's usually the most up-to-date imagery. And then the way to do that, there is a video on Chelsea's website, but I think the link that we gave the first time around no longer works to add this in, but what you'll want to do is right click on it, new connection, and then you'll name
I suggest that everyone do this right now.
And then I did find a different website as well that I'll put in the chat that kind of has a bunch of links for a bunch of different base maps that you can add in.
And so Rachel, can you put in the link? Yeah, and then the link in chat for the URL that they need also.
Mhm.
If the Google Earth satellite imagery isn't there, is that what you're giving us right now?
Yes.
Yes.
Okay, cool, thanks.
And so let's, Rachel, wait while and make sure that everyone has the Google Earth satellite loaded.
Okay.
You'll need this for the first homework assignment. Christy, no. This is, we're going to come back to this data in a second, but this is what you need to do to be able to get a Google Earth base map in QGIS. Otherwise, you just have OpenStreetMap, which is pretty useless for geology. And
So
so
Rachel,
that,
you mentioned a tutorial on the website. Is that a tutorial on how to load Google Earth into
yes.
QGIS? And that's on the class website under the QGIS tutorial?
Yes.
Okay.
That
I
link's
think
dead also.
That one is also dead. Okay.
I copied the one from that website and it worked,
This one,
the satellite one.
The link like attached to the YouTube page did not work, but you said this one worked, Mindy, the Google satellite?
Yeah.
Okay.
okay, and then so you can see what Rachel has, or you want to put the link in, Rachel?
Yeah.
And then yeah, so give it a name. That's what you're going to see here under XYZ titles. It's the name that you put in that first window, and so give it something useful. And then can you press, is everyone here? So Ob says, are both links working for you? Chrissy says,
Still working on it here a little bit.
So to bring up that window, you need to right click on the XYZ tiles. And then I believe you say load a new, make a new connection. And that will then open up the window that Rachel just had.
Sorry, are we supposed to put in the link that is like google.com? Because I feel like it's not working when I'm clicking on it.
Can you maybe, Rachel, just start over and go very slowly?
Yes.
Okay, so yeah.
So on the left side, we'll have the browser. You'll scroll down to XYZ tiles. You'll right click and then go to new connection. And then you get brought to this page. You can name it whatever you like. This is just for your reference. I'll put Google Earth satellite. And then for the URL, the one that was put in the chat was the one that worked for you, Mindy?
I copied it from that website you posted.
Okay, so this first link that I put, the GIS Stack Exchange, if you go to that website and you scroll down, it kind of, if you keep scrolling, there'll be sample URLs for different kinds of base imagery. We'll want to scroll down to the Google satellite link, and then it will copy it, go back to your QGIS and paste it in here. And then are we all at that point so far? Okay. And then you should just be able to click OK, and it'll add in right here. You won't see it yet unless you add it to your active map, but with it correctly uploads right there, then you should be okay.
Can you show Rachel how to then get it on, to see it on the screen?
So there's one of two ways. You can scroll it down, you could drag it into your layers panel, or you can put it directly on the map.
And be careful if it puts it above or below other items. So here it's on top, so it'll cover everything else. But if it automatically goes to the bottom, which it often will, then you may not see it. So just make sure the other layers are turned off before you worry that it's not there. And yes, we will pause. So let's, wait a few minutes for people to catch up. And if you have any questions, can put them in the chat, or better yet, say them out loud.
So one question here from UNR is when you drag it into either the window or the layers file, it just shows up as white. It doesn't show up as the imagery. So, and even trying to zoom to layer, it doesn't find it. So any ideas on why that might be?
My guess is you didn't load it correctly. Maybe you didn't put the link in correctly, or maybe you put a space and it didn't recognize it.
So just troubleshoot, try to load it again with and make sure the link is properly in the field with no spaces and stuff like that.
Yeah.
Is it check that added a space at the end? Yeah. Oh yeah, no.
Yeah, it's working now. It was just that added a space in the end when we added the link in. So, so everybody's up and running here now.
Excellent. How's everyone else? So I think the next thing is Rachel's going to show how to make hill shades. Is that correct?
Yes, I'll show them how to, once the data is done processing and they can upload it on their own. It's very easy once you have the data to put it into QGIS, but I'll show you.
So I guess I'll put a link, and I just processed some topography data. And then maybe Rachel, could you go to that, with sharing your screen, slowly go to that link, and then let's download that data and load that into QGIS and show how to make hill shades with this data. And we'll try to go a little more slowly, but again, if you have any questions, please don't hesitate to ask.
Yes. So if you click the link, it brings you to the job results that Chelsea processed. And you'll see down here, it kind of visualizes it as a hill shade already for you. But you'll want to download the DEM, this DEM 10 output 10 TARS D. So if you click that and start to download it. And it's a zip file. So
yeah, you get this tar file, and then inside that is you're going to find your TIFF. And so essentially you just have to keep on opening the files until you get to the TIFF. And then the TIFF is what QGIS will actually open. And it's a GeoTIFF, so that means that all of the pixels have a georeference.
So if you get the, if you need to install an external unzipper, you can do that too. But if you do get the TIFF file opened okay, you can put it in whatever file you like. I like to have everything for like one assignment organized in one file, just so all the location and pathways are clean. We could take a sec too, also.
So now what we're trying to do is get you to have the TIF file on your computer, wherever you would like to have it. And so I'm downloading it right now, and I'll put it in the chat, which is another way to get it, or I can email it as well.
This will be the same data that I tried to upload to the website, but Chelsea processed it on the side while we were working through the beginning. So it'll be the same thing that we tried to upload earlier.
So does everyone have this TIF file on their computer in a place where they know where it is located?
Sorry, could you share it in the chat? Because I think I will have to download the WinRAR or something like that to extract it.
Here, I'm uploading it to email. It's too big to send in the chat.
Okay, great.
Just do the DEM, Christine.
So I just sent it in the email. If you just added the class recently, you won't get it, but I can send it again.
While you're doing that, Chelsea, the Wallace Creek, the link that's in the schedule to the Open Topo to download the Wallace Creek link, which I think is the like polygons, has expired. So is that something you could send an email as well?
That's Rachel's. I don't have it, but we'll make sure that you get it soon.
Okay, thanks.
I think it's a link to the job for the DEM. So you can like resubmit it and have it send it to your email, but that's what Chelsea just sent us.
So that was just a random area. Just so we got something for making the hillshades for right now. So that's not exactly where your assignment will be.
And I'll email Chelsea the shapefile also, so you guys can have that of the mapping polygon too, so we can send that to you as well.
Oh yeah, so Christy asked, do you want to download the point cloud or DEM file? So for everything in this class, we're going to be using the raster file, and that is saved as a GeoTIFF, and the file, last letters of the file name are TIF. And so for the class, that's exclusively what we're going to use. But for reference, the point clouds are saved as an LAZ. So it looks like we're good. So Rachel, do you want to continue showing how to load that data and then make the hillshade?
Yes. And then I emailed you the shapefile for the mapping polygon. That one can be done much later. It's very simple to upload that. But once you have your TIFF file in a location that you would like to store all of your other files, you can do it one of two ways. If you're up on your folder, you can simply click it and drag it in and copy it in, or you can locate it from whatever drive you're using. I'm using a D drive, but you can kind of toggle onto your computer to wherever you stored it, and it'll be right here as well. And you can drag it down into here.
So you want to open the output.10.tiff.
Mm-hmm. And it'll automatically go to the top. You can organize your layers like Chelsea said. The one on the top is going to be on the top. So if you have your base imagery on the very top, it's going to obscure all of your other layers. But you can right click on it once you have it loaded into your layers and hit zoom to layer. And that'll bring you to our base VEM. Does everyone have that sorted so far?
I have it in there. It's just not showing up for me.
Make sure you click zoom to layer and make sure it's on top.
Got it. It's just being really slow.
Yeah. So you can always, or often tell for features in QGIS, they're a DEM versus other products, is DEMs are often pretty smooth, and they'll open up at this white to gray scale. And here you can see some rivers, streams, dried streams, but it's typically you can't see that much in the data.
All right. So the first thing we're going to want to do, and this might be helpful just to see where we're going to be mapping. So I'll put the mapping polygon on. You can import it once you guys have it the same way, either dragging it from the folder or toggling from your browser and dragging it into your layers. But here is the mapping polygon. This is where you guys are going to be doing your mapping for your assignment. And if you want to change the color of the mapping polygon for whatever reason, you can double click on that layer and it'll bring you up to the layer properties. You'll want to go on the left side to symbology. And this way you can change the color to whatever you prefer. Make it easy. And then you can hit OK. And you can do that for any of the shape files that we're going to teach you how to create. You can right click on anything. It'll bring you to the layer properties. You can find out the source. Like if it does get convoluted, it'll show you where you've placed it. There's attributes. There's just a bunch of stuff in here, but mostly you're going to be using. Mm-hmm.
Can you go to information?
Yeah.
So one thing we're going to want to always know is the resolution. And this is usually indicated here. Can you scroll down? Not here. Anyway, I'll tell you in a few minutes how to find the resolution. It's usually here. Anyway.
Another really important thing to know when you're first uploading a base map is the coordinate reference system. I think that's what it stands for. But normally it will be set to what this is right here. Sometimes you will download data that's going to be in a different coordinate reference system than normal. So when you do create new files, and I'll show you how to do that in a sec, you'll have to make sure the reference systems are the same throughout. Otherwise, things might not display.
You want us always in WGS 84?
That's what the majority of it will be. It's that's what I think.
If you turned your line work in WGS 84, that would make our life so much easier. So
I don't think we're going to be giving you guys any data that's also not in this reference system either.
Cool. Could you copy and paste what that says? Because it's really hard to read and I have a feeling People
Yeah.
who have never seen this before will be confused.
So this WGS 84 is it's essentially latitude and longitude. And then you can see below a little bit, it says unit of degrees. And again, that's consistent with latitude and longitude. And it may only be that for meter scale data sets, it says the resolution.
And we won't have to work too much into this or know the nitty gritty of it, just so as long as everything is in the same coordinate reference system is all you really have to worry about. And the same, oh, sorry, we were on the mapping polygon. That's why you didn't see the resolution. But you can see how this one is a different CRS. But they're close enough that when you map everything, it should be fine. It's only when it's like something drastically different where it's maybe not even an EPSG or a completely different reference system that you're going to run into problems. But as you're mapping and they're showing up where you want them to show up, it should be fine. Okay, so now does everyone have the base map sorted and we're ready to start doing the hillshade? Cool.
Yep.
So once we want to make the hillshade that Ramon said, it kind of gives you a nice artificial display of elevation from artificial sunlight coming in whatever direction you specify. So to get that going, you'll go up to the toolbar to raster. We'll go to analysis, and then we'll go to hillshade, and it'll bring you up to this window. You'll want your input layer to be your base map. So mine's already set to the output 10 base map. This Z factor, vertical exaggeration, we won't have to worry about too much. It's only going to make a difference if the base map is in one set of coordinates, and then we have, like, if the base map was in latitude and longitude, you would have to implement the Z factor. But since the base map is in meters, we don't have to deal with the Z factor at all. And same with the scale.
But if you do SRTM, a hillshade from SRTM, then you do. So just keep note of that.
Mm-hmm. And then this azimuth of light is going to be direction 0 to 360, where you want the sunlight to come in to illuminate the surface. And it'll come in handy when you have kind of like maybe a lot of slope change, and the shadows that are created from the artificial sunlight can obscure some of the surface features, which is why it'll be helpful in the assignment. We want you to make more than one of these so you can try and see all angles of the surface to see if the shadows are obscuring anything. And we'll show you how different they can look, the surface, depending on what light you choose. So for now, we'll just keep it at 315. We'll keep the altitude of the light at 45. You won't have to change that. And then right here for the hillshade save to temporary file, we're going to want to go over and say save to file. And I like to have it in the same place that I'm housing all of the other files. And you can name it however you like. I like to put what the file, what the azimuth of light is in it. So you'll know that's like the hillshade 315. You can save it. And then you'll hit run. You'll see that right here, that when it's finished, it already puts it up right there.
Or before you exited that, one of the nice things, at least in my opinion, of QGIS is it did just show us the formula, the command, which you can see. Rachel, can you hover over the GDOL OGR? Yeah, so this is then the command that QGIS is executing to run the hillshade. So it's good to know, I think, what the computer is actually doing. And this is this line is one level deeper to understanding the what's happening. So let's let people catch up for a second before making another one.
Okay.
Are there questions on how to make a hillshade? Any disadvantages using on-the-fly hillshade?
Yeah, so I was gonna mention that too. There, I'll show you the other way that Ben is talking about. The advantage of using the on-the-fly hillshade is that you can look at many different light angles at once. Maybe the disadvantage is you can't necessarily save that specific light to its own file after the fact. So if you do want to go back and look at it, you would have to go back to the on-the-fly instead of toggle directly to the hillshade file that you've saved.
Are there any questions? Has everyone made the hillshade?
You saved as a temporary file.
So if you or go ahead, Rachel.
You'll go down to hillshade. I went to save to file because I want to keep the hillshade along with the rest of my mapping files. So I would go to save to file and then label it however I like, and then save it within the rest of them or whatever folder you have.
Okay, and also input layer, you said it was a base map, so the Google Earth image.
I didn't quite catch that.
Sorry, yeah, you said that the base map, the input layer was supposed to be the base map.
Yes, yeah, so the output.tin will always be the whatever base layer DEM that you've downloaded will always be the input layer for whatever kind of raster you're trying to do.
Right.
So Mara says hers looks pixelated. It often looks pixelated if your Z factor is wrong or if you make a hillshade of a hillshade. So make sure that when you make the hillshade, your input is always the output.tin file, which is what Rachel has right now. And one way that you can assure that it always uses the DEM is that if you have this selected when you go to make a raster, then that will be the default. But you can see then when it outputs the hillshade 315, it'll actually keep that highlighted. So then if you go to make a hillshade immediately at your next step, then it'll try to make a hillshade of the hillshade. And that's when you get to problems. Is it possible I'm seeing actual cows in this hillshade? Maybe. Bushes.
I just said if they don't move while the plane's collecting data.
Yes.
Also about the pixelated, sometimes if it's zoomed all the way out, it might look a little more pixelated. So if you zoom in, it might clear up. Yeah.
So planes are fast, Christy, but this is actually collected. To get this data, the plane flew northwest in about 5 different flight paths. And each one it got a few hundred meters. And so, yeah, they're fast, but if cows are in the boundary, then they'll probably have moved. All right, does everyone have the hillshade?
Sweet. And so I quickly wanted to do a different angle just so I could toggle between them back and forth and show you the difference between them. So I chose 45 this time, did the same thing, named it Hillshade 45. I'm gonna run it. And then you can start to see how different the landscapes look depending on what light you have here. The drainages have a lot more shadow on one side, or the northwest side, and this side they're not illuminated, but you can't see the definition of the features as easily. And then what Ben was mentioning earlier is another thing you can do. I'm going to do it on this guy. This is the same base map, but if you double click on the base map, you can go back to our symbology page, and where it says render type, you can hit Hillshade right here. And then it'll show you, you can kind of actually grab this or enter it into azimuth, but you can change the light however you like from where it's coming from and apply it. And that's a really easy way if you want to look at a bunch of different light angles and you don't want to necessarily render and save a file for every single one. This is a good tool to use if you just want to kind of skirt around with it a little bit to find maybe the best angle and then save that one. The base map will be the DEM. So if we're all sorted with the hillshade, we're now gonna go over the slope shade.
Wait, so Rachel, there's just a good question of terminology to be careful with. So
Yeah.
base map that's often would refer to the optical imagery, or what we have here is the Google Earth. And then the DEM is better called DEM.
Yes, I'll say DEM. Sorry, that was probably confusing. But now we are going to do a slope shade, because we'll also be having to compute one of those in the assignment. And this will show you regions of areas with high slope or change in slope. So we'll go back to raster, back to analysis, and then we will go and hit slope. It'll be the same process. You'll see how it wanted to put the input layer to the last thing I selected. You want to make sure it's going to the output 10 or DEM. You won't have to worry about the band number or the ratio. This one is pretty simple. You can directly go to save to file and save it however you like. And again, like Chelsea mentioned, it'll show you the GDAL, what they're actually computing for the algorithm. And so we'll run that. And it's good. You'll want to move it to the top so you can see it. And so right now it looks very dark and you might not be able to see much. So something you can do is to right click on it and you can change it from black to white to black. Once you apply that, you'll be able to see the differences a bit more easily. The range of the slope is from 0 to 90 degrees. And you'll see right here with this data, it's 0 to 80. You can change these if you like. If you think there's too much white and not enough black and you'd like to see more differences, you can kind of lower or raise the min and max, but for the most part, what it computes will be fine. And so with the slope shade, you can start to see some of the changes in slope where the drainages are going to have steeper channel walls than others. That's the slope shade. But then for the next one that we have to do is the contour map.
So wait, we have about 10 minutes of class left.
Yeah.
And I want to explain the assignment.
Okay.
What else did you want to show today?
I was going to do contour, but I already ran it because it's going to take a long time. So I already ran it for them, but just showed them how to get to it and how to change the interval.
Okay.
And then how to export it if they want to draw on it for the assignment.
Okay.
So for the contour map that you'll have to make, we ask for a 1 meter contour. So you'll go to, and this one, since it doesn't have a video on our QGIS tutorials right now, you'll have to reference back for it if you need it, but we'll go to raster again, extraction, and on a contour map. You'll want to, again, go to your DEM, and the interval between contour lines is going to indicate how far apart you want the elevation intervals to be taken. Right now it's set up at 10 meters, and then we'll want to take it to 1. We will save it the same way. The closer resolution that you choose, the longer it's going to take. The 1 meter one will probably take like 1 to 2 minutes, so it'll take a little bit longer. But once you do have it, it'll look something like this.
So
it is a little,
go ahead.
It'll look a little dark from far away, but the closer you get, the more detail you can see. If you would like to increase the interval, you can, but with the 1 meter interval, you're able to see a lot of the morphology of the area that you're going to want to use for the assignment.
The contour is a fairly compute intensive calculation. So for the size of a DM, 1 meter is fine. But for some of the other data sets, you may want to first make a 5 meter or 2 meter contour and just experiment with how long that takes. Or perhaps just do it on a smaller portion of the bigger data.
Okay, and so since we still want to explain the assignment, I'm going to quickly, yeah.
Are there any questions?
You don't have to show it, but I'm just want to ask for the slope. Is there a way to, instead of having it a stretch from 0 to max, white to black or black to white, is there a way to categorize it so you bin it by like slope range and then colorize that?
Yes.
Okay.
Similar in the way if you've done it in ARC, it'll be similar that way, and I can make a video on it later too and upload it to the website.
Cool, thanks.
Properties, symbology, and then graduated, I believe. So I just put a link here. So this is QGIS videos that I made that go over most of what we went over today, as well as a few other items. And so feel free to refer to those videos. QGIS is often used by many people, and so there's a number of other web resources, web pages, as well as videos that you should feel free to consult.
Yes. And then at the end, we're going to ask you to do some mapping on here. If you are comfortable enough with this software and would like to map on QGIS, you can, although we're not asking that at this point at all. It's probably going to take too much time. So you can go to project, export. You can export the map as an image or a PDF, anything that you would like to be able to draw on it with.
And we'll show you later how to make a shapefile in QGIS. Yes, you can draw with a pencil. You can print it if you'd like and scan it. This first assignment is focused on what we've shown you today for the software, and then I want you to focus otherwise on the mapping.
This will be the hard part. I swear, I was just trying to get all of this sorted, and then after that, the fun will begin. But that'll be a quick and convoluted intro to QGIS. I can record some videos to that of things we didn't touch on or things that might have not been clear, and I can upload them to the website too later.
So Rachel, we had a question here at UNR. So are the shape files that are generated for slope and contours and stuff, are they compatible to just load up into ARC? I know we're not using ARC for this class, but are they directly exportable and then you can load them into ARC or what?
If you
Yes.
go, yeah, they are. If you go back to where you save them, you'll see that they're just simple TIFF files when you compute them, so they should be able to load into ARC.
They
Okay,
are.
great.
The only thing that won't be is style files, but otherwise the line work and the TIFF files from this course are completely compatible with ARC.
Cool. So we are going to show, and I know the video that Ramon made to introduce this topic is 11 minutes long. So if you can't stay to watch all of it, I completely understand. We're gonna upload it immediately after class to the website for you guys to watch. He kind of explains a little bit more about what we want you guys to do and learn from the assignment, but in conjunction with the assignment PDF on the website, those will be the two things you need to get started. So if you have to leave sometime during the video, that's completely okay.
In this first exercise for our class, we want to talk about mapping landforms in a very basic sense with applications to geomorphology and earthquake geology. This one focuses on simple mapping, and hopefully also will teach you a kind of a interpretive sequence where we start with more of the observations and try to then go to more of the interpretations and try to always come back to that. And so this was something I did, and I've developed more broadly and have applications for a couple of places in California. But this exercise that we're doing for our class is just for Wallace Creek. So you can see where it is in California along the San Andreas Fault. But before we get into Wallace Creek, what I want to talk about is morphological mapping. And it's so basic, I think some people are like, wow, this seems so trivial, but it's kind of like a simple language of morphology where each of the elements that we map is kind of like a letter that we use to build up the words for the landforms. So see if you like that analogy. This was originally I found this paper by Savagear, who is a British physical geographer who laid down this idea. But that basic idea is if you take a landscape like the one in the middle here, and let's not worry about the geology so much, let's just worry about the morphology. And so we see that it's comprised of these different segments of slope, of hill slopes and channels, and those are separated by certain transitions. And so we have like flat to kind of rolling over to a cliff, to this slope with some kind of a micro slope in it, and on down to the flat to the slope, and then this channel. So that's the description, but how do we document it? What are our words so that we can give, and our letters, our language, our graphical language that we can use to systematically characterize this landscape? And so here's a suggested one that he had, which is these kinds of, angular convex break of slope. So that's right here on the map, which would be what that break would look like. And you see the steep slopes on the edge of the channel. This is this kind of little teeth on one side where it's pretty sharp. You can see that then when it's the other pattern, which in other geologic maps we might think is a thrust fault, but here it's an angular concave break of slope. So that would be this one here, and concave meaning it's like upward facing in terms of the opening, whereas you see this one be downward facing, so that's why that one's convex. And we see the cliff has this kind of somewhat ugly rampart looking pattern. So this is the idea. And then these the gray just shows these zones of steeper slopes between 5 and 40 degrees. So again, trying to give us this graphical representation of this landscape. So let's go. So that was 65, and then by later, modified in 75 and even later, is this map. And so here it's kind of like, well, what kind of mapping do we want to do? So again, we have this landscape now. It's a little bit more complicated than we saw before, and has some geology in it. So we can see it's some dipping layers and then some landforms like this little landslide, and I forgot what this funny thing is, and then the channel, and then a little kind of valley fill, this gravel that's filling the valley. So again, we can go back to our morphological mapping symbols and map just the shapes of the landscape. And that is kind of what we want to do in this exercise as is the sort of beginning step. But from a morphologic map, we can go to more interpretation. And so there's geologic map, morphogenetic map, process map, hydrological map. You know, the geologic map, we would add more information because we might, you know, go in the field and say what the rock types are that we see. Some of these other ones are a little bit more kind of like the morphogenetic map is how did this landscape get to be the way it is. So it's kind of a genetic, meaning how it formed. But a lot of interpretation there. Process map, here's what processes are operating over this surface. And so TR is like a transitional landslide. And hydrologic is kind of what's the water doing. So, you know, it's kind of always the first question you want to ask is what kind of mapping? And so let's start with a morphological map. And so we're going to do that at Wallace Creek along the San Andreas Fault, which is a really famous place with clear evidence for active faulting. It's basically a plate boundary. And so our goals are that you'll have some basic skills in handling base data and then using those information to map, to delineate landforms. And so the tasks are you're going to load a bunch of these base maps in QGIS, make a morphologic map, and then a geomorphic map and identify the major tectonic landforms. So there's this kind of progressive interpretation from just base data to morphology to naming things and putting where's the fault. And so, you know, here we see this sort of suggested morphology. So you could use the patterns that were provided in the examples I had from Savagear or this, which is a little bit of a simpler version. And you can see, so like Sharp Ridge, this little railroad track, this would be, you know, the line would be on the top of that ridge. Whereas this convex slope break is this one, concave slope is this one. And if they're gentle, you might use a slightly different pattern. Trough on the slope, ridge on the slope, flat. Couple different ways of doing drainage, different surfaces. So we want to do lines, points, and polygons. And you know, you can modify it. You don't have to use this, but just be consistent. And so here's the topography. So this topographic map that you'll produce contours. This is based on digital elevation models from airborne laser scanning from the B4 project. And so it's just contours, but already we start to see things we can interpret. But I want to really push you to use this morphologic mapping idea as a way to force yourself to cover the entire map zone. So we don't want blank areas. And just because there's, you know, an area doesn't mean you have to find a fault there. You might only find one fault. But we want to still map where, you know, everywhere we can to, you know, indicate where the slope breaks are. So we see this flat valley here with kind of a sharp upper break and a sharp lower break. Those two sort of feed into another set of breaks. So this ridge line here. So we just want to work through systematically with our language and just start marking. And so again, it's kind of like the exercise of doing this is almost more valuable as a process, because then it forces you to look everywhere. And what I show here then is just a couple to try to get you started, where we kind of show the upper and lower breaks on the either side of that depression. And so that's the first step. But then if you do it where you turn off your base data, you can start to see this abstraction. So this is the morphology of the landscape. And then as we progressively interpret, as we move to the right, then we can say, okay, well, this looks like this is a valley bottom. So I can put a polygon there. And finally, I put the fault in. So I think it's very important that you keep mentally thinking that faults are late in our interpretive process. You don't start with the fault and work backwards. You're like, oh, well, here's the fault. I guess I need to draw this, you know, offset channel. It's more like, no, let's define what's here. What are the again, this kind of letters that make up the words that make up the paragraph of this landscape, and let's progressively abstract and then interpret. It's extremely important that you do it. And you want to have also even level of detail. So this is me doing a quick demo. I think you could have a little bit more detail, but you want to have whatever level of detail that you employ, it should be even across the entire map. So don't leave blank areas, because if there's a blank area, we don't know if you looked there. So you want to always find something to map in every portion, but you don't want to have too many lines too close together. So kind of even mapping. If this was a piece of paper, what I'd like to say is every thumb print on the map is where I'll put at least one observation. So because you're doing this digitally, you kind of have a variable scale, a lot of times, or zoom level, but you kind of want to try to keep it at a constant zoom level so that your line density stays about even. And so here's an example of just another view of that same area from when I did this on a chalkboard once. And so you can see again some of the lines. So you can see this railroad track here is catching the top of that ridge right there. And here I'm trying to do the top and bottom of these slopes that are sort of bounding this little valley and so forth. And then I'm interpreting, then I put that sort of valley floor in. You could map other features, ridge tops if you want, that are, you think, representative of some polygonal, domain. And then finally, again, in red here, I'm showing where I put the fault. But I waited to the end to do that. So I think it's very important to have that progression of interpretation. And then finally, you could play around. If you have a piece of paper, you could cut it along the fault and think about reconstruction. And then as a final point, just one of the parts of the assignment is to name some of those features. So this is a classic kind of 3D model of this landscape that's dominated by strike-slip faults. And so there is a sort of, designation of some of these names of features. So this would again be at the end of your interpretation sort of workflow. You would start to mark and label and name things. And here's just an example of that in another part of the San Andreas Fault, where I tried to show, what those things are in this particular landscape.
Okay.
All right.
Yeah, be a good intro to the assignment. But if you have any questions at all still on that assignment or any QGIS questions, please email me. I can meet with you one-on-one via Zoom too to troubleshoot any problems.
Yeah, and so the point of this assignment is really to develop observational skills and language skills for doing that morphologic mapping, where we're really just describing the shape of the landscape. And then in this assignment, we do ask you to identify the faults and landforms. But we will spend really the first month, but in some sense the full semester, teaching you about this process. Ian, does anyone have a good tutorial for how to make custom lines? You mean for different symbology, lines with different symbology? I don't have a tutorial. We're going to make those files for you later. So you will never have to do that in the semester. So I would say don't spend your time making a slick QGIS file.
Thanks, everybody. UNR signing out.